Assalamualaikum. My name is Merajun Bristy. So today we will discuss about topological sort. My first point is ordering tasks based on requirement and it's an object. Second one is task and prerequisite relation is represented as directed graph. Third one is a directed edge from U to V means U has to be done before V. And last one is the graph must be acyclic in order to have valid sorting, otherwise no solution is possible.
Let's talk about how can we present our problem into graph representation to for topological sort. Here you can see that there is a directed edge between A to B to A, and which indicate that if we want to complete task A, we must complete its prerequisite B, and another is task is C to A, which also uh, indicate the same possibility. Based on our graph, we can see some possible order, which is ABC, which means that uh, task A is completed before B and C. But according to our condition, we need to complete task B and C before A. So this possible order is invalid, and there is another possible order, which is BAC, where B task is completed before A, which is totally correct. But in case of C to A, where A task is completed before C, which contradict to our condition, so this is also invalid. And another possible order is BCA, where both B and C prerequisite task is completed before E, so it match our condition, so this is valid. And another possibility is CBA, where also both of the prerequisite condition B and C is completed before A. So we can now draw a cyclic graph which indicate that both B and C are prerequisite of A. In another word, we can say that B and C have to be done anytime before A.
Now I am going to discuss about valid graph for topological sort. In my left side, I draw a graph. The name is directed acyclic graph, and it's valid. In my right side, I draw a graph. Name is cyclic graph, and it's invalid. Why cyclic graph is invalid for topological sort? Because according to example, if we want complete the task A, then we need to complete that its prerequisite B. Similarly, for if we want complete the task B, then we need to complete that its prerequisite C. Similarly, if we want complete the task C, then we need to complete that its prerequisite A, which create a collision, and we cannot which one is prerequisite. That's why cyclic graph is invalid for topological sort. Now,
Moving into the implementation using DFS, there are a lot of technique being used to implement topological sort, but DFS is most popular because it is easy to apply, easy to understand. So our there is another graph our, and we will based on our technique will be we will apply this DFS or another what is which called depth first search algorithm. We will apply this uh, algorithm into our each node of this graph, and when we find a unvisited child, we will put into our list, and after visiting all the nodes of this graph, we will get a list, but we need to reverse this list, and now the reverse list will be our topologically sorted order. uh, there are more than one topological sorted can be found in any acyclic order, but there must be one minimum topological sorted will be there. So we will simulate our DFS. How can we apply it in our algorithm or graph? Let's see it. So here is a, graph where is four edges and five nodes. We'll start from applying from number one. Before that, we need to store all the uh, nodes which is already visited or not. For this reason, we will use a vector result list which will store our result, and we are using it uh, integer data type because on data are given in integer. We can use it also another like maybe structure, maybe double type in later based on our problem. So start from number one nodes. We cannot put it into our list yet because node one has a child node which is 2. We need to move to our adjacent node 2. After that, we find that there are two unvisited child which are 4 and 5. We need to move on, and moving to 4, we can see that 4 has no children, so we can now put it into our result list and move back to the number 2. We can see that number 2 has another child which is number 5. So number 5, after now visiting number 5, we can say that there is no child of 5. So now we can put it also in the list and moving back to the number 2 nodes, because all the child node has visited already, and now we can put in into our list. Moving back to number one nodes, we can now put it into the list. But we can see that all the nodes of this graph is not visited yet. So according to our algorithm, we need to apply DFS algorithm before visiting all the node. So now we need to apply number 3 DFS, and we can see that 3 has a child. True, but it is already visited, so uh, it has basically no children need to be visited. So now we can put it into our list. So we found a result. So, but our algorithm indicate us that when you get a result list, we need to reverse it because reversed list will be our topological sorted. So answer is 3 2 1 5 4. We can say match, or we can check it here you can see that number 2 tasks is need to be completed after 3 and 1, so it matched our result. So moving back to our code, here we used our DFS algorithm, and we take input uh, from the user, how many nodes or how many edges they have, and after that we call DFS algorithm, and here we go, and we will apply our node result based on our graph, and we can see that topological order match our result, which is 31254. So here is the overall introduction or overall description of topological sort. There are more possibility or more application around in us, and if you have any question, you can put it into our comment. We will try to answer those comment as soon as possible. Thank you very much.